Is it recording?
Yeah,
Welcome. Today we're going to be talking about Frama-C. I'm Reed Lawrence.
and I'm Michael Irvin.
So today we're going to be going over an introduction on what Frama-C is. We're going to be going over some example programs that Michael and myself wrote. We're going to be going over an evaluation of Frama-C on a larger open source project. We'll look at some related works of Frama-C. Then finally, we're going to talk about some of our conclusions and thoughts on Frama-C as a testing framework. And then we also have our references included in the slides. So what is Frama-C? Frama-C is an open source platform dedicated to the analysis of source code written in the C programming language. Frama-C is a platform that gathered together multiple analysis techniques into a single framework. So the focus of Frama-C as a framework is not allowing any bugs through. Thus, there will be more false positives saying that there are bugs in your code, but conversely, there will be fewer false negatives saying that there are no bugs present when there are indeed bugs present. Frama-C generally uses static analysis, but it can also use dynamic analysis when it comes to using specific plugins within Frama-C as the framework. So we are going to be going into a few live demonstrations. First, we're going to be just looking at a simple for loop and how Frama-C deals with that. We're then going to be looking at a larger poker hand evaluator. And then we're going to see how Frama-C can help us look at constraints on a program. So to call Frama-C, I'm just going to do Frama-C GUI. And then I'm going to call that on the program that I want to evaluate. In this case, we'll look at simple.c first. So it'll open that up. You can see the source code on the right, which again is just a simple for loop that increments in values of 2. On the left, you can see how Frama-C is representing this, and it has unwrapped it into a while loop that has the initialization of I on the outside of that while loop, and the incrementing of I within that while loop instead of all of that being on one line. So I can go down here and click run, and Frama-C did multiple things right there. The main thing that has done for this program is that it will point out what values each variable has at certain points. So for example, on this line, after it runs, you can see that I can only be 0, which makes sense. We can see that I can be any even number from 0 to 10 for when checking the condition. However, I will only print out even numbers from 0 to 8. Then we can see that here, before and after this call, I can be any even number from 0 to 8 before it, but after it can be any even number from 2 to 10. And then we can see that this program returns 0. So that is a very simple example, but it is already showing us how powerful Frama-C can be. But if I were to call Frama-C GUI on poker.c, which is substantially more complex, the first thing that I'm going to do is I'm going to scroll down and click run. And at this point, multiple things have happened. But one thing that we want to look at is one of the constraints of Frama-C, which is that it does not work well with custom structs. For example, here I'm creating a card struct, and I'm putting it into temp 0, or in this case, it would be inside the array deck. And from there, we can see that if we go to values, it returns this really long item that is not very user-friendly. One other thing I would like to point out is that Frama-C managed to break each function into these different tabs. So this would be the main function. These are functions that check specific kinds of hands. And we can see that Frama-C is automatically putting in certain assertions that need to be held for this to work well. But on the right, you can see that those assertions are not there. However, you can also see that all of the functions are inside one file. So these are some very nice things that Frama-C can do. So for the last of these examples, we're going to call Frama-C with the tag WP. And this is going to help us check some constraints on our code. So we're going to check some constraints on the program equal.c. You can see that Frama-C checks 7 goals, but only 6 out of 7 of those goals passed. In this case, goals are going to be equivalent to constraints on our program. So it also tells us which goal did not pass and for what reason. If we were to go and look at equal.c, you can see that we were able to specify some goals that we want Frama-C to look at specifically to see if these invariants hold. Now, there's only 4 there. We want to also check with the Frama-C to see what it thought of our program, and it caught that based on everything that we've done here, we can't say that we won't try to access memory outside of bounds. So it warned us about that, and thus proved that we need to work on that program a bit more. Now I'm going to hand this over to Michael, and he's going to talk about our work on an open source project.
So for the open source project we went over, it's called the algorithm/C, which is a repository of common algorithms implemented in C. And we used C because Frama-C works with C code. The uses of Frama-C is that it can be used to test correctness of the implementations. It can be used to show simplified versions of the functions as Reed had shown in the previous examples, along with showing what constraints are implied for the program to work function correctly, also shown in the previous examples. The example we used from the open source project is a file called Naval Battle, which is a game that acts similarly to Battleship, which I will demo in a little bit. So here I am in my terminal. I'm going to run the program with /naval, and here's the game itself. So to put down a battleship, you will say the coordinates, and I'll use 1A, and there you can see it placed down a ship there. And then I'm just going to go ahead and place down other places just to populate the board a little bit. And then I'll put this last one at 1D so there's room for it. And then once you go to boat size of 2, if you try to place down a battleship, it won't actually place down anything. So if you try running that again, it will get stuck in an infinite loop, which Frama-C will point out in the once I show that off. So I'll run the command Frama-C GUI navalbattle.c like we did in the previous examples. And once I run that, it'll open up Frama-C. Here you can see the source code, what Frama-C has changed it to, and then the different methods on the side here. So I'm going to go ahead and run Frama-C. You can see it's already pointing out a bunch of different errors. And if I were to scroll down a little bit, this highlighting here shows dead code, which somebody who's programming it can see, and then they can evaluate why it's not working and then fix the code so that all of it works correctly. You can place down battleships of different sizes, and that I won't get stuck in infinite loops, an infinite loop later on. Fairly related works, we worked at 3 tools. We had Parasoft, Flaw Finder, and Helix QAC. Parasoft is a code analysis tool for C and C++. Flaw Finder is a code analysis tool that focuses on security issues, which Reed showed off with equal.c that showed if there were any security issues. And then Helix QAC, which is a code analysis tool that focuses on ensuring that bad code does not enter production, which if you were to merge it and not know that there were bugs, you could have more technical debt down the road. And then it also implies more false positives similar to what Frama-C had done. For our conclusion, we said that Frama-C works well with standalone files, computationally complex algorithms, and constraint-bound programs, which Reed had shown off in his examples. And then it struggles with custom structs as seen in poker.c and highly integrated programs it also doesn't work really well with. For references, the first one is a Frama-C user manual. It talks about what Frama-C is and allows you to see different functionalities and commands you can use. The second source is going off of the WP tag that Reed had used for our last example. It then here's the file itself if you want to look in the repo and look at the code. And then this is just where we got our code analysis tools that were similar to Frama-C. And that concludes our presentation.